My name is Snehal, and today I'm going to demonstrate Team Pangea's architecture evolution tool. As we have already mentioned, our tool will be extending Acme Studio. Acme Studio is a diagramming editor for drawing component and connector view of an architecture. So for the demonstration purpose, we'll be using a system, call it as a data center system, and its CNC view that has been drawn using Acme Studio is shown right here. So this is the current architecture we have, and the CNC view of the architecture diagram which is shown right now is the future envisioned architecture. Now the evolution tool will help an evolution architect to diagram this evolution process from the current architecture to the future architecture, and also analyze the different paths that might exist during this transition. So let's look at few of the key functionalities that an evolution tool provides. To begin with, we'll make an evolution diagram that will allow diagramming of an evolution path. So few of the key elements I'm going to discuss are shown in the palette, our architecture instance, transition, and path. Let's begin with architecture instance. Drag this architecture instance palette tool and drop it on the evolution diagram. I'll name it as DC System 2. So ultimately this architecture instance will be linked with the current architecture that we have. So to make this linking happen, the easiest way is to drag the DC System 2 from the package explorer and drop it on the instance. Will show up all the available Acme systems you have in the file. Select the desired one. Usually you have multiple instances on an evolution path, so I'll go ahead and do that. And you will be linking all these instances within Acme systems. And after that you will use the palette tool called transition to connect these architecture instances. And this is how our tool will allow an evolution architect to diagram a path. So next step he might want to do is to define the path, and that's when you will use this palette tool called path. So use the path tool and click on the instance on which you want to begin your path, and subsequently keep clicking on the instance that you want on the path, and finally double click on the last instance on which you want to end your path. A pop-up will show up, name the path, and if you see the property view of the editor, you will find a tab called path visualization, which will list out all the paths for this evolution diagram. In this case we have P1. This is how you will visualize it. So for this, these are the few basic diagramming features that our tool will provide. So for the demonstration purpose, I have this neat evolution diagram from DC System 2 to DC System 2 end, and as it is shown, we have two paths, P1 and P2, as highlighted to achieve this transition. A next step evolution architect might want to do is run different analysis over this evolution diagram to see which path is better to take. So we have written a simple cost benefit analysis in which an evolution architect can input properties such as benefit and cost for an instance, and properties such as cost and time for a transition, and he will input values for all these instances and transitions in the evolution diagram, and then he will run the analysis. The analysis will show results for both the paths in terms of benefit, cost, and time, and the evolution architect will make sense out of this data to choose a path. Another interesting feature that our tool has to offer is to compare two architecture instances and show the differences graphically. Remember that each of these instances is linked to an Acme system, so comparing two architecture instances will result in comparing two Acme systems. I just clicked on the compare button and it showed a compare editor. I'll just zoom in order to see it. How we are showing the differences graphically. If you see any Acme component or connector, it's been annotated with these signs. So this Mantis server that the cursor is on shows a matched sign. The other annotations could be an added one, a deleted one, or an updated one. And the compare editor will also show limited interaction between the matched or the updated element. For example, if you select on the Mantis server and from the corresponding view the matched element got highlighted and a blue border has been shown against it. So this is how you will come to know that which element is matched to what. And we have this horizontal scrolling, vertical scrolling, as any comparator would expect to have. So this is and there are certain elements such as switch T1 which has been added, which is not present on the left editor but are present on the right editor. That means during this transition those elements got added, and that's why this sign plus is shown on this component and the connector. So these are a few of the main features that our tool has to offer. So that concludes our demo, and now we'll move on to the EOSP.